Hi, I'm Lee Easton. I'm one of the tutors at tutorhero.net, and I come from the UC Berkeley PhD program in economics. I have studied a variety of economics, but I especially have focused on microeconomic theory and financial economics. Prior to attending UC Berkeley, I went to the University of South Carolina, where I studied mathematics and philosophy. I did well in both of those areas, winning awards. But more importantly, from your perspective, I have a lot of experience tutoring students and teaching. So I've taught classes at UC Berkeley, including intermediate microeconomics. I've also assisted with course preparation for professors, meaning writing problem sets, writing exams. So I know what professors are going for when they teach these classes. I know what kinds of tricks you're likely to see, and I know what kinds of difficulties students face. And I love to help students meet the challenges that professors are laying out for them. So here are some of the subjects that I tutor. So in economics, essentially any undergraduate level economics class, I have the background to help with. In particular, I like to focus on microeconomics. So being a microeconomic theorist, microeconomics is particularly interesting to me, and I cover microeconomics from the introductory level all the way up through the graduate level. With macroeconomics, also I cover intro to graduate level material. Game theory is another area that I have spent a lot of time focusing on. I find it very enjoyable. I know that a lot of students struggle with the different way of thinking about things that game theory puts them into. And so I've had a lot of experience helping students to understand the mindset of game theory and how to approach that. I also offer tutoring in finance, which some people take in a business school setting, other people take in an economics setting. Whichever setting you're coming from, I can help you with that. For my undergraduate days, I learned a lot of mathematics, and I'm still help people with calculus, real analysis, and topology. Statistics as well. I help people with introductory stats and mathematical statistics. And for my days as a philosopher, I can still help you with your logic class. In particular, if it's a symbolic logic type class, I'm probably a good choice to help you out. So if you need to contact us, you can come to the website, tutorhero.net. We have a email address here for you. And if you have any questions, feel free to let us know. We have people who are around available to answer questions to help you determine if who the right tutor is for your needs. Okay, so today we're going to be working on a problem that could come from an intermediate micro class. Actually, it's adapted from a problem from an intermediate micro class. And this problem is what we call consumer optimization. So we're going to have a consumer. This person is going to have a certain amount of money to spend, and they're going to have some things to spend it on. And those things have costs, and the consumer will derive utility from those things. And what we want to find out is what is the best thing for the consumer to do? And this is, in some sense, the fundamental question of intermediate microeconomics. So there's a lot of things that you can do after you know how to solve this question, but as a starting point, this is the fundamental question. So in this particular problem, we have a consumer named Susan. She has a weekly budget of $50, and she can spend it on one of two goods. So she can consume pizza or she can consume soda. And both of those goods have a cost. Pizza costs $3 per slice. Sodas cost $1 each, so pizza is more expensive than soda. And she has a utility function which explains to us how she derives utility from these two goods. So we write the utility function u of ps means that the things that go into her utility are the two input goods, pizza and soda. And her utility is given by 2 times the log of pizza plus the log of soda. So for utility functions, you don't want to think too carefully about what the numbers mean. The numbers just give you a ranking of the different goods. So the point of the utility function is that it explains how she trades off between the goods. So the kinds of questions that you're going to be asked to answer for a problem like this is the starting point is usually that you're going to be asked to illustrate the situation graphically and to point out on the graph where the utility maximizing choice occurs. You will also frequently be asked to solve analytically for the utility maximizing choices of the two goods. And so we're going to do both of those things today. So what does a graph look like in this case? Well, what you're going to start with is you're just going to start by putting some axes out here. And on the one axis, you're going to put one good, and on the other axis, you're going to put the other good. Now, which good goes on which axis? Well, it doesn't matter. So either axis is equally good for either good. So completely arbitrarily, I've chosen to put pizza on the y-axis and soda on the x-axis. Now, the first thing you're going to want to draw in a graph like this is you're going to want to draw what's called a budget line. So the budget line is going to represent the set of attainable combinations of pizza and soda. That is, it's the set of combinations of pizza and soda that utilize precisely your entire budget. So how do you draw such a thing? Well, you ask yourself the question, how much pizza could I buy if I chose to buy nothing but pizza? Well, pizza, you have your total budget of $50, and pizza costs $3 each. So how much could you spend on just pizza? Well, it's 50 divided by 3. How much is that? It's about 16 2/3. So you're going to have a point here, and let's just leave it as 50 divided by 3 for now. So we don't really need to express it in more direct numbers. So we know that. So we know that you could buy 50 over 3 of pizza. Now we ask ourselves the same question for soda. Soda costs your budget is $50 and soda costs $1 each. So 50 divided by 1 is 50. So how much soda could you buy? Well, you could buy 50 worth of soda. And so I'm going to need to extend the graph a little bit to make sure that we have room for that. And so we're going to put a point on here that's 50. And so what does the budget line do? The budget line just runs between these 2 points. So the budget line is representing the trade-off between pizza and soda. The slope of the budget line is representing the ratio of prices. So pizza costs 3 times as much as soda, so the line slopes down at a rate of 1/3. So you could give up, to get 50 sodas, you could give up 50 over 3 pizzas, and that ratio holds within each thing. To get each additional soda, you need to give up 1/3 of a slice of pizza. So the slope of the budget line is minus 1/3. Now, what else do we need to illustrate this? So we've illustrated what the consumer's constraint is. Now we need to illustrate sort of what it is that they're trying to do. And so the consumer is going to have indifference curves. And for today, we're not going to worry about precisely how you draw the indifference curves. So we're just going to sort of sketch them out here. So here's an indifference curve that exists. So what does an indifference curve represent? An indifference curve represents different combinations of the good with which you would be equally happy. So you're equally happy at this point here as you are at this point here, as you are at this point here. Even though those are very different combinations of the good, they all make you equally happy. Now, we also need to know in what direction does increasing happiness go. And the direction of increasing happiness is up. Let me use a different color for that. Is up and to the right. So what does that mean? It basically means that more of both goods will make you happier. Now we ask ourselves, what does a utility maximizing choice look like? Well, consider the indifference curve that we drew to start with. Now, ask yourself, could the person do any better than that? And the answer is yes. So while there are points on the budget line that this indifference curve hits, there are points beyond that in this region where the person would be happier than they are in this curve, but which are also attainable. So if the indifference curve is intersecting the budget line more than once, or if you could also say if the budget line is intersecting the indifference curve more than once, then you haven't achieved an optimum because there's room for improvement. Now we could also consider another indifference curve somewhere out here. We could ask ourselves, could the consumer's optimum choice lie on this curve? But the answer is no, it cannot, because this curve is not attainable. So it's all outside the budget line. So this curve is outside your budget line. You can't attain it. You would certainly be happy with it, but it's not possible. So what kind of curve do we need to have that makes you be at the optimum point? And the kind of curve that you have, the optimum, is a point that just barely touches the budget line at exactly one point. So at that point, there's no room for improvement. So you can't go up anywhere from this curve and still be within the budget line. But it is attainable because at that precise point, you can precisely afford that combination of goods. So graphically, that's what a utility maximizing choice looks like. So now the second part of this question is, how do you solve for the utility maximizing choices? So this is a graph, this is a picture of what it looks like. It will look something like this. But in terms of what are the actual numbers, we're going to have to solve for that a little bit differently. But I'll make one final point about the graph, which will help us transition into the analytical solution, which is that there's something important about these indifference curves. So indifference curves represent the rate at which you're willing to trade off one good for the other. So at this point on the indifference curve, you're very willing to trade pizza for a little bit more soda. So for just a little bit more soda, you'll give up a whole lot of pizza. You can tell that by the slope, right? If it slopes steeply, you're giving up a lot of pizza for each additional soda. Over here on the indifference curve, it's very flat, so you're not willing to give up very much pizza at all for additional soda, or alternately, it requires a whole lot of soda to compensate you for giving up a little bit more pizza. Now, what's happening at this special point here? Well, that special point is the point at which the rate at which you're willing to trade the two goods is precisely equal to what the market is offering you. So the budget line indicates what the market is offering you in terms of trading the goods, whereas the indifference curve represents how you're willing to trade them. At the optimum, those two things are precisely equal. And that's going to lead us into finding our solution to the problem. So let me retype our utility function here because we're going to need that. And so it was 2 log p plus log of s. And let me also retype the budget. So the budget was $50, and price of pizza is $3, and price of soda is $1. So the way you find this analytically, and this is the fundamental result in intermediate microeconomics, is that at the optimum, something that's called the marginal rate of substitution will be equal to the ratio of prices. So what does that mean in this case? And in particular, what is the marginal rate of substitution? So the marginal rate of substitution is the derivative of utility with respect to the first good divided by the derivative of utility with respect to the second good. Now, it actually doesn't matter which one you do first as long as you're consistent. So du ds over du dp would be equally valid as what we wrote. But for our purposes, we'll keep it as du dp over du ds. And we want that to be equal. So at the optimum, this needs to be equal to the ratio of prices, which is 3 divided by 1, or 3. So in order to solve this, we're going to need to take those derivatives. And so what is the derivative of u with respect to p? So if you remember your calculus, the derivative of log of x is 1 over x. So the derivative of 2 times log of x is 2 over x. So the derivative of 2 log p is 2 over p. And the derivative of log s with respect to p is 0. So you get a 2 over p for that. And what are you going to get in terms of du ds? Well, you're going to get a 1 over s by the same logic. And so we want to simplify that a little bit. So what does that simplify to? Well, if we combine our fractions, it's going to simplify to 2s over p. And that needs to be equal to the price ratio, which is 3. So what do we do at this point? Well, we need to rearrange this a little bit to get an equation expressing s in terms of p or p in terms of s. So what I'm going to do is multiply both sides by p and divide both sides by 3. And what I'm going to end up with is 2/3 s equals p. So this is a relationship expressing that at the optimum, the amount of pizza consumed will be 2/3 the amount of soda consumed. So that doesn't quite tell us what Sandy does, or Susan does, but it does tell us how the relationship between these two goods is going to be at the optimum. So we need one more thing to actually finalize the solution, and that one more thing is the budget constraint. And so we need to be able to express that budget constraint mathematically. So before, we wrote it out on a graph and we drew it, but we never solved for an actual equation. But the equation is easy enough to write. So the budget constraint is always of the form wealth equals something. And so we're going to have $50 equals something. What is it going to equal? Well, it's the price of one good times the amount of it you consume, plus the price of the other good times the amount of it you consume. So what does our budget constraint look like in this case? Well, we've got 50 equals 3p plus 1s, or 3p plus s. So what does that mean? On the left side is the total amount of money you're spending, and on the right side is also the total amount of money you're spending, but expressed in terms of the two goods. So 3p represents the total amount of money spent on pizza. 1s represents the total amount of money spent on soda. So what do we do at this point? Well, we have one equation here, which expresses something that has to be true at the optimum. And we have one equation here, which expresses what are the feasible combinations that you can actually purchase. So how do you get your answer? Well, you combine them. And what do I mean by that? Well, I literally mean that you're going to plug in for p into the budget constraint. So if 50 equals 3p plus 1s, and p equals 2/3 s, then we can rewrite this as 50 equals 3 times 2/3 s plus s, which can then be expressed as 50 equals 2s plus s, or 50 equals 3s. And so s is going to equal 50 over 3. So this is your utility maximizing choice of soda. Now, we have one more thing left to do to find the final answer. So we know that s is 50 over 3, and we know that p equals 2/3 of s. So therefore, to find our final answer for p, we know that p must be equal to 2/3 times 50 over 3. And that number precisely is equal to 100 divided by 9. And for most classes, you just want to leave it in this form. So you can see that not always is the answer a whole number. And this is just the nature of the way that we as economists approach these problems. So one of the critical assumptions underlying these problems is that the goods are infinitely divisible. In real life, that may not be possible, and so people would have to approximate this as closely as they can. Nevertheless, the real-life answer will be as close as possible to the theoretical answer as the person can get. Okay, so we have our graph, we have our answers, and those things together constitute the entire solution to the problem. Now, professors can make this trickier in various ways. They can change the budget constraint, they can introduce more complicated utility functions, but the fundamental steps to follow are uniformly going to be the same. And if you can solve this type of problem, then you can solve more or less any problem that you're going to face later in the class. So I hope that you found this helpful, and if you appreciate our style, if you appreciate this way of solving problems, then you're going to want to contact us at tutorhero.net. You can email us at tutor@tutorhero.net, and we will help you find either me or somebody else who is appropriate to your needs. Okay, thanks for taking the time to watch this, and I hope you're having a great day.